Hello, I'm Andrew Hollis, and welcome back to another episode of Making Waves. Today we have a very special guest. His name is Mike Stark. He is currently the chairman of Envirogen Technologies North America Business, was a founder and first CEO of Envirogen. He was also the former president of U.S. Filters Operating Services, a past CEO of OMI and Veolia Water North America. Mike has been involved in the water and environmental field for over 55 years. Today, he will share his experience as a leader in the water industry. Firstly, we want to thank you for joining us today, as we are honored to have you here with us, Mike. Now, to get on to some of our questions, what do you believe are some pressing issues within the water wastewater industry that need immediate attention?
Okay, first of all, Andrew, thank you for having me. It's an honor to be asked, and I appreciate it very much. Obviously, the major issue is funding, is having the appropriate funding to take care of the actual problems. But the market issues include, but wouldn't be limited to things like acid mine drainage in the Appalachian states like Kentucky, West Virginia, Ohio, and then there's the California drought, which is a serious problem and requires funding for new facilities. When it comes to the California drought, and you talk about funding, there's a bit of an interesting play there, because people complain about spending $3 to $4 for a gallon of gasoline, but they think nothing of going out and buying bottled water, which winds up costing them $6 to $10 a gallon. Mm-hmm. So funding really for water facilities shouldn't be that big an issue. Other issues are looming industrial groundwater contamination. And I would say also, from an operations perspective, it's a tremendous shortage of operators, especially when it comes to trained and licensed operators for managing and operating the facilities that we build.
Yeah, I definitely couldn't agree more on that last piece. So then, kind of to segue off that, what are some of the issues we're dealing with in terms of quality of water across the nation and in regards to hazardous chemicals that can be found in the water, like PFAS?
Yeah, so quality, the requirement for quality is going to be forever linked to analytical capability. As these capabilities improve, we're going to be able to measure more compounds more easily and more economically with a faster turnaround time. And we're also going to be able to measure into much smaller quantities. We used to talk about measuring in milligrams per liter or parts per million, which is 1 part in a million parts. And we thought that was pretty phenomenal. And pretty quickly we progressed to measuring in terms of parts per billion. And now we measure things in terms of parts per trillion. So as the analytical capabilities are increased, the non-detect disappears and we find more detectable contaminants. So quality is going to be forever linked to analytical. But as far as compounds like PFAS, and we'll talk about PFAS in particular, it's all about advancing technologies. If you look at PFAS, the way one would treat PFAS today would be to use ion exchange and or granule activated carbon. But it's a very expensive way to go, because you can only use the adsorbent or absorbent one time, and then you can't landfill it or the PFAS will reemerge. So you wind up incinerating it to get total destruction. But even in those cases, there are instances where PFAS has been found to be airborne. Mm-hmm. And so the cure for PFAS in particular is going to be advancing technology, is being able to take that concentrate off of the IX, or if you can recover it from the carbon, which I doubt, but off of the IX, and then be able to destroy that compound in its concentrated stream, which would be a much smaller quantity to deal with. And in fact, there are companies who are piloting biological and oxidation methodologies for doing that now, but it really is in the pilot stage. So until then, we're going to be relegated to using ion exchange and granule activated carbon for treating PFAS.
Mm-hmm. Well, thank you so much for that. Given how the federal landscape has changed due to the funding in regards to the Infrastructure Act, tell me, even regardless of that, some of the infrastructure funding issues that we are still facing within the water wastewater sector.
All right. I mean, you're right to mention the Infrastructure Act, and there's also the abandoned mine land funds that are being made available for AMD. So there is funding that's coming slowly, and there are the cures for that problem, which we'll talk about later in the podcast. But in terms of the myriad of issues we face, it's aging and antiquated unit processes, which are expensive to maintain. And the older they get, the more expensive they are to maintain. There are things like lead pipe, which is still in existence, and the sediment from lead pipe, which when you clean the pipe becomes a real threat to the local users of that potable water. There's the abandoned mines that I talked about, which contribute to groundwater contamination. And there's just a myriad of industrial facilities that have been contaminating groundwater for a very long time. And because those facilities are still in operation, they're really not being faced with pressure for cleanup of those facilities. So, we have to worry about those things. And then there's the natural issues like California drought we mentioned several times earlier, and we call it the drought, but I'm afraid in the case of California, there's been a drought for so long it's actually the new normal. Mm-hmm. So I think those are the issues that we're currently facing.
Yeah, no, I mean, I completely agree with you on that. It definitely appears like that's a new normal out in California. So what has been the most difficult water treatment problems to solve to date?
All right. So, rather than trying to pick a compound, let's talk about the type of problem if we can. So I've always found that the most difficult water treatment, wastewater treatment issue to address is when you have high variability. You have high variability in flow, you have high variability in contaminant, you have high variability in concentration. And sometimes that's due, again, to drought, and sometimes it's due to industrial production schedules, and it comes from a whole host of reasons. And obviously, the best way to approach that would be point source treatment or recycle. And I think that some of the recycle scenarios require some rethinking. It's true that we have some older plants that don't have the capability to isolate, and we have to invest in the infrastructure to isolate. But then there's also some cultural issues, like just an example of that would be the expression of toilet to tap. I mean, people cringe about toilet to tap, but yet it's readily available technology in a lot of ways. And we use it in the space program. Our astronauts use toilet to tap. Mm-hmm. So there's no reason why we couldn't use, toilet to tap. Then there's also the issues of emerging contaminants, such as 1,4-dioxane, and previously we mentioned PFAS. The water industry has always been entrepreneurial and creative. So there are always new technologies coming out. And I think that's going to stay that way. I mean, we are a creative bunch. They talk about one man's garbage being another man's bread and butter. And I guess that fits us. And we are a creative bunch. And so technology advancement is going to be in the fore. For instance, there's a company called NX that manufactures nano filtration membranes now that'll handle 300 parts per million of solids, unheard of before. here's an advancement in membrane technology. And then there are technologies like Envirogen's FBR, pardon the commercial, Andrew, but there's like Envirogen's FBR, which is able to handle changes in flow and concentration much more rapidly than commonly used bioreactors. The FBR is a fluidized bed reactor, and it'll handle wide flow changes and concentration changes quicker than a fixed bed reactor or an MBR or an MBBR.
Mike, first of all, that was a great commercial.
I had to get it in. NX didn't pay me anything for their commercials.
Well, thank you so much. And honestly, given the innovative nature that Envirogen had for the FBR, it just makes sense to mention it in this context. So thank you so much for that. I want to go back to an earlier topic that we touched on, and it might be slightly repetitive, but I just wanted to highlight a little bit more on what are some infrastructure related issues in the water industry kind of outside a little bit of what we spoke of earlier.
So outside of funding and things of that nature,
Mm-hmm.
I think one of the key issues, I think we have a serious philosophical capital facilities procurement problem in our industry. We tend always to talk about capital cost. And there's tremendous competition in both the industrial and the commercial markets for capital funding. And so people tend to look at capital funding, and in the municipal market, it's capital funding. Where's the capital coming from? And I think we have to change that mindset. I think we have to start looking at life cycle costs. We have to change our offering in this industry. Life cycle costs don't just consider capital costs. They do consider capital costs. They worry about the time value of money when you do a life cycle cost calculation. But you also think about maintenance costs. You also think about energy costs. You also think about online reliability and the compliance and the cost of non-compliance, the fines and those things. So when you look at a project, instead of just looking at the capital cost, look at the life cycle cost and be prepared to do an evaluation, not just on capital. And it makes me smile when I think about it, because one of the best lines I heard that described this whole problem came from one of our astronauts, Alan Shepard, first guy to orbit the Earth, right? And he was asked after his flight, how did it feel to be the first man to orbit the Earth? And he looked at the reporter and he said, let me ask you, how would you like to go 100,000 miles away from Earth and then return in a spaceship built by the lowest bidder?
Fair point. Fair point.
I mean, he was much more concerned about the life cycle than he was the capital cost. I guarantee you that. So we have to think about life cycle costs.
Mm-hmm. Thank you so much for that. So then moving on, how do you think we can ensure, kind of touching on, kind of the quality question as we did earlier, how do you think we can continue to ensure high quality water supply that doesn't harm the environment? And what ways can we increase the overall drinking water supply in some of these drought-stricken areas, for example, like California or Arizona?
So, I mean, I think we've really, if you take the aggregate of questions you've asked to this point and the answers, I think that to a large part, we've answered the question previously, but it's worth restating. I think it's appropriate to restate that we need technological advancement. We need a change in the bidding philosophy. And we need to think about recycle and reuse as keys to sustainable water supply and an increased water supply.
Yeah, agreed. Agreed. Thank you so much for highlighting that. Really, that'll go a long way, I think, to our listeners. And reaching the final question that I kind of want to touch on today. What can we do as leaders within the water wastewater sector? And do you think there's a fundamental shift that is required so that we can continue to build a better future?
Okay. Yeah, I think the fundamental shift is required from the service providers. I really do. One poignant point we need to make here, as I said, is there's definitely a shortage of qualified operators in this market, and the existing population is aging rapidly. I believe the average age of operators today in our industry is over 50 years of age. And we're not attracting a lot of new people. They don't see it as a glamorous industry. They don't hear about it, and they don't see it as a glamorous industry. But besides operators themselves, I think the industry needs to revise the offering around, as I said earlier, life cycle costs, which means that our offering cannot be risk averse. We have to, they always say, don't do as I do, but do as I preach. In our case, I think we have to do as we preach. We have to be a lot more risk averse. We have to be a lot less risk averse. What we have to do is, when we make an offering on a life cycle cost basis, we need to be willing to stand behind that and warranty those life cycle costs. If the client can guarantee us an influent that stays within a certain specification, then we have to be willing to say, okay, and we guarantee this will be your life cycle cost. This will be the life of the facility. This will be the cost of your chemicals. This will be the cost of not the cost of your chemicals, but the consumption of your chemicals, the quantity of chemicals you use. This will be the quantity of energy you have to use. This will be your maintenance requirements, and we guarantee it. If you use more chemicals, you use more energy. If the maintenance is higher than we suggest, we'll stand behind it and we'll take that risk. So that's one thing. We have to be less risk averse, and we have to be willing to warranty the life cycle costs that we project when we operate a facility or when we offer a facility. And I think there's little reason why we should offer facilities that we don't offer to operate. Our customers are great at doing what they do. They convey water to their customers. They take care of all of the needs of their customers. On the municipal side and the industrial side, they make products and they offer services. We treat water. So we should take a strong stance in doing that and offer to warranty those. But in addition to that, we should be very cognizant of the fact that if we're going to sign a long-term agreement with our client to be involved with that client, that we have to include in our thinking keeping that facility up to date. And if there are new developments that come along that would enhance the operation of that facility and reduce the cost of operation of that facility, we should offer that to our client. And in doing so, everybody benefits, because if we offer it to our client, we put up the money, we account for the cost for doing that, making that improvement, and then we share a portion of that savings with our client. So our client benefits. So we're incentivized to do it because we're going to benefit. We're going to have a facility that's easier to operate and less costly to operate. And we're going to make a better margin, which we should. Mm-hmm. And our client's going to benefit because they're going to get updated treatment facilities at no cost, and they don't have to compete with the capital appropriation system that they live with to get funds to do that within their system and compete with production. So I think it's absolutely critical that if the fundamental shift has to be towards life cycle costs, better operations, and a continual alliance between between provider and end user.
Couldn't agree more, Mike. Well, I want to thank you so much for your time, and thank you for joining Slater Infrastructure Group on our latest episode, Making Waves.